So, good morning, students. So, I welcome you in the lecture of discrete and signal processing. So, let me choose first pane. Okay. So, in this lecture, we will discuss about the fast Fourier transform. This is the very important topic as far as your syllabus is concerned. Nearly you will get a 10-mark problem based on this, either on DIT or DIF algorithm. So, what exactly mean by DIT? That is the decimation in time. What exactly mean by DIF? That is discrete decimation in frequency. So, that concept we will discuss with the help of problem. So on this topic you will find a 10-mark problem each. Either you will get 10 mark each, that is DIT separate or DIF separate. Otherwise you will get at least problem on DIT, otherwise on DIF. So you will expect at least 10-mark question, minimum 10-mark question definitely you will find. So this is what you can say extension version of the FFT, the fast Fourier transform, the sorry DFT, so discrete time Fourier transform. But in the fast Fourier transform, the calculation speed is what you can say it is minimized, the minimized one. You can calculate within the minimum time. So I welcome you everybody for this lecture. So you have to put your attendance in the comment box. I will see afterwards. So as we know that the DFT, that is the discrete Fourier transform, what we are doing, we are calculating the frequency domain component, that is nothing but the x of k, by writing the formula summation n is equal to 0 to n minus 1, where n is the length of sequence, either 4 point, 8 point, 16 point, or 2 point, whatever. And x of n is my sequence. X of n is my time domain sequence, and e raised to minus j 2 pi n k divided by n, capital N. This is the nothing but the how much point DFT you have to calculate. Okay, then if my sequence in the frequency domain and I want to convert this is in the DFT, what we are doing, time domain sequence we are converting into frequency domain. Okay, and in this case, if you are having sequence in the frequency domain, we are sequence in the frequency domain, we are converting into time domain by writing the formula. How, what is the formula? That is nothing but the 1 by n, 1 by n is nothing but the length of DFT, that is nothing but IDFT, sorry, length of IDFT, that is 4.2.8.16 point, like this one, 2 raised to multiple something, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, like this one we have to write down. So x of k e raised to, here that is not j over there, minus j only, 2 pi n k divided by capital N. So in this case we will require n square complex multiplication and n into n minus 1 number of additions. So the if the bits are very large, then it is difficult to calculate the DFT. Okay, DFT for this one. So what we are doing, we are calculating the IDFT, sorry, we are calculating the FFT algorithm. By using FFT algorithm we are calculating the things. So I will move to the next point. If you are having doubt, you can ask me in the comment box. I will so this is all about the DFTs. Don't, what you can say, mm, don't get panic about this. So the in the DIT algorithm, there are two algorithms as far as the FFT is concerned. FFT is concerned, fast Fourier transform. I will use FFT short form of this one. So in the FFT, you will find a two algorithm, that is nothing but the DIT, decimation in time. The second is DIF, that is nothing but the decimation in frequency. So what we are doing in this case? So what we are doing, we are taking n by 2 number of even samples first, n number of even samples, and second n by 2, that is the odd sample, and we are multiplying this with the one factor which is called as Tweedle factor over there. Tweedle factor over there. So what exactly mean by Tweedle factor? I will explain this thing to you. So this W here, you will find a W of nk. So in this case, what is W? So W will be defined as, W is defined as the thing summation everything, okay, from summation x of n e raised to, not x of n, sorry, this term only, e raised to minus j 2 pi n. This is nothing but my W. Okay, W is nothing but Wedel factor is nothing but W is equal to e raised to minus j 2 pi 2 pi n. Okay, 2 pi n. this W and this factor, twiddle factor, this is also called a twiddle factor. This whatever this called a twiddle factor. So this and this are the same one. Just what we are doing, we are multiplying this with n, this W, n we are writing over there. So n is written over here. And k here we are writing k over here. So these are the remaining one. These are the nothing but the similar one. So this is a just what you can say representation. We can say representation in this case. So we are multiplying just what we have to do, we have to split the result in the DIT domain in the two odd samples and even samples. Odd samples and even samples. So even sample we have to write down as it is, and odd sample we have to multiply with the twiddle factor. So don't get panic. Wherever we are solving the problem, we have to what we have to, we will get the concept in detail one. So then what you have to do in the first case, again suppose 8 point DFT is there, 8 point DFT. So what we are doing, we are calculating 4 point first. Okay. Then again n by 2, that is nothing but the 4 by 2, that is nothing but the 2 point. First of all 8 point DFT we are calculating. Then again 4 point DFT and again 2 point DFT. This what is exactly mean by 4 point 2 point, that we will see while solving the problem. So what we are doing in this case, for half domain, that is the 4, we are giving the even samples to this. Okay, even sample to this. And in the second half, we are giving odd sample to this. We are giving odd sample to this, and we are multiplying this thing with the, what we can say, we are multiplying with the twiddle factor. And at the result, we are getting the output. At the result, we are getting output. So this is overall idea. So I will go to next slide. Yeah. So this is a twiddle factor exactly. Twiddle factor, sorry, butterfly diagram. So butterfly shape is there like butterfly. So it is called as butterfly. Where is my pen? Okay. This is a shape of butterfly. Like this one, I think so. Okay. Somewhat butterfly is there. Okay. So butterfly structure is there. That's why it is called as butterfly structure. So we have to use this structure. So how? I will show you in the next slide. Okay. This is the overall idea of the 8-point DFT algorithm. So what we are doing, we are using odd sequence first. Sorry, even. You will find a cat voice over there. Okay. So x of 0, x of 4, x of 2, x of 6. These are the odd samples, even samples. Then x of 1, x of 5, x of 3, x of 7. How to remember this thing? How to remember this thing? So what you have to do, you have to calculate what are the events after odd samples 0, 2, 4 and 6. Okay. So how to write down 0 and 6? You have to write down as it is. I have written 0 and 6 as it is. Then shuffle this 4 and shuffle this 2. Then that is nothing but shuffle this 2 and shuffle this 4. So like this one again for even odd samples. What you have to do, how, what are the even samples for odd samples for me? 1, 3, 5 and 7. So how to remember this? 1 and 7 as it is, and 3 and 5 shuffle this sequence. Just shuffle this sequence. So this is nothing but my first 2-point DFT. Okay, we are calculating just 2 points. So this is the 2 point, and this structure is called as my butterfly structure. This structure is called as butterfly structure. So somebody is saying that draw the butterfly diagram for the 8 point. So you have to write down first 2 point, then 4 point, and then for 8 point. Okay. So here why 2 points? Because 2 points are involved in this case. First 2 points are involved, then second 2 points are involved, then third 2 points are involved, and fourth 2 points are involved. In the second stage, what we are doing? We are adding this 4. So these two we are adding in this case. So it is nothing but my 4 point EFT, 4 point. This is 4 point again, and we are merging all these points. So we are getting x of 0, x of 1, x of 2, x of 3, 4, 5, 6, 7. Okay. So simply calculating this, we are getting the DFT. As previously, you will get a lot of time for this, but your time is minimized in this case. Okay. So, and what you have to do in this case? So we are writing the twiddle factor. So for I will explain this twiddle factor, each and every twiddle factor. Yes, you have to remember what is twiddle factor for each and every stage, each and every stages. Okay. So we'll solve problem based on this. Then every concept will be more and more clear over there. Okay. So the sequence is given to you that x of n is equal to 2, 1, 2, 1, 1, 2, 1 and 2. So you have to compute the 8-point DFT x of k by using first nothing but radix DIT FFT algorithm, and second is nothing but radix to DIF FFT algorithm. So you have to also plot the magnitude and phase plot for the set. So how to calculate? First you have to write down the sequence. So x of 0 I have written as it is, x of 1 I have written as it is, x of 2. So that is nothing but x of 0, x of 1, x of 2, x of 3, 4, 5, 6 and 7 over here. I have written over here. Then you have to shuffle the order because in the DIT algorithm you have to shuffle the order. Okay, shuffle the order. So x of 0 as it is, x of 4 is nothing but my 1, x of x of 2 is nothing but my 2, x of 6 is 1, x of 1 is 1, x of 5 is 2, x of 3 is 1, x of 7 is 2. Okay, so you have to remember that the examiner is asking about DIT algorithm or DIF. If the DIT is there, then you have to shuffle the order. Keep in mind, there is a difference in between these two. In the DIT algorithm, there is a difference that you have to shuffle the order in this manner: even sequence first and odd sequence second. Even sequence first and odd sequence second. Okay, so you have to do. And in the DIF algorithm, the sequence is as it is. You have to put. So I have changed the sequence. So input is like this one, and the diagram is already drawn to you. So here the twiddle factor is half. You have to use the twiddle factor. So minus one you have to use over here. Half minus one, half minus one. That is first one multiply, then minus one multiply, then one multiply, then minus one multiply, then one multiply, then minus one multiply, one multiply, and then minus one multiply. I have drawn. I have written the sequence: 2, 1, 2, 1, 1, 2, 1, 2, like this one. So you have to trace like this one. So 2 into 1, how much? 2. You are getting 2 over here. Then this 1, here is 1, this 1. 1 into 1, how much? 1. 1 plus 2, 3. So you have written over 3 over there. Second case, that is nothing but a 2. You have to start from the topmost start. 2, I have written over there. Then 1, multiply with this minus 1. So how much? Minus 1. So you are getting 2 minus 1, how much? 1 over there. 1 over there. Then here, again, 2 as it is, into 1, 2. Then 1 into 1, how much? 1. So we are getting 2 plus 1, how much? Here you have to write how much? 3. The second case, you have to always take the uppermost point first. 2 into 1, again how much? 2. And 1 into 1, minus 1. So 2 minus 1, how much? 1 over here. Okay. Then second case, this is the 4 point you have calculated. How much it is? Values are 3, 1, 3, 1. So next case, so 1 into 1, how much? 1. Then 2 into 1, so how much? 2 into 1, 2. So 1 plus 2, how much? 3. You have to write 3 over here. The second case, 1 into 1, I have written 1 over here. And 2 into minus 1, how much? 1. Sorry, 2. So 1 minus 2, how much? Minus 1 over here. Again, this point, 1 into 1, 1 I have written. 2 into 2. You are not going, we are going like this one. So that's why I have not written minus 2 over here. So 1 into 1, 1 you have written. And 2 into 1, 2. So 1 plus 2, 3 over here. So again in this case, 1, I have to go like this one. 1 into 1, 1 I have written. And 2 into minus 1, minus 2. So we are getting minus 1 over here. Minus 1 here. So this is the first point calculation. So this is nothing but my, this is nothing but my 2 point 2 point DFT calculator. 2 point first stage. Okay. So second stage we will calculate then. Okay, are you getting? If you are getting, give me thumbs up in the chat comment box. Okay, second stage calculation. Whatever the first stage calculation, if these points are correct one, then you have to go for the second stage. If they are wrong, then you are totally wrong. Okay, so twiddle factor are there. That is nothing but the W 4 is to 0 and W 4 is to 1. Okay, these are the twiddle factors. So half you have to write down 1, and for half you have to write down how much? Minus 1. And W 4 is to 0, its value is how much? 1 over here. I have written over there. And for this This W4 is to 1, its value is minus j. I have written over there. So similarly, write down over here, that is a 1, 1, 1 and a minus j. Why it is minus j? Because its value is, we have to take like this one. So just take. So how we are doing this thing, that I want to tell you, that for half point, that is 4 point, this is a 4 point, okay. So this is a 4 point calculation. So second stage calculation. So first 2 point you have to write down 1 over here, okay, W4 is, and the second and then half point you have to write down W4 is to 0 and W4 is to 1 over there, okay. So W4 is to 0, everything it is to 0 is 0, so sorry 1, so here we have written 1 over here, and W4 is to 1, it is value is minus j, okay. No need to remember this thing, you can easily remember this thing, okay. So second stage I have written, that is 3 1 3 1 and 3 minus 1 3 minus 1, okay. So the calculation of second point 12 factor is nothing but 4 raised to 0, it is nothing but e raised to 0 is 1, and W4 raised to 1, that is nothing but e raised to minus j 2 pi divided by 1 by 4. So this 2 will get cancelled, so e raised to j pi by 2, so its value is cos minus pi by 2 plus j sin pi by 2, so its value is how much, its value is minus j over there, okay, its value is minus j over there, that I have written over there. So again, now concentrate very quickly. First you have to start from the topmost one. 3 into 1 into again 1, I have written 3 over here, so this point is like this one. So 3, nothing is minus 1 1, okay. So 3 into 1, so 3 plus 3 how much, 6 over there, okay. Second one over there, so 3, sorry 1, I have written over there, and 1 into minus j, so minus j over there, and it is going over there, so 1 into minus j, so 1 minus j over there. Then third point, 3, just a minute, I will rub this portion first, okay. 3 minus sorry 3, we have to go straight over, we have to go straight, so 3 over here, okay. 3 I am going over here directly, so 3, and don't go, what is the remaining, what point you have to remember, that topmost point you have to calculate first, मतलब we have to consider first. So 3 over there, and this 3 into 3 minus 3 over there, so 3 into 3, 3 minus 3 0, in the third, in this case, in this 4 point 3, okay. Sorry, here, sorry, just a minute, the structure you have to remember only, okay. So this point is remaining, so here 1 into 1 over there, and it is coming over there, so 1 I have written over there, and 1 minus j, so 1, and this is again minus 1 over there, so this is nothing but the 1 plus j over there. So for half point you have to write down 1, and half point you have to write down minus j over minus 1 over there. That first stage we have calculated, or first stage we have seen that for half point you have written 1, and half you have written minus 1. So uh, the even point calculator we will see. So 3 into 1, so we have written 3, and the second point is coming over there, so 3 you have to trace like this one, 3 into 1, so you have to have 3 plus 3, so he will give 6 over there. Again for this point, minus 1, it is going directly, so minus 1, and the second point is coming over here, so minus 1 into j, so plus j over there, so minus 1 plus j over there, you have written over there. For third point it is 3 into 1, 3 I have written over there, and 3 minus 1, that is nothing but the minus 3, so 3 minus 3 0 over there. So for this point minus 1, it is going directly, okay. Then minus 1 into minus j plus j and minus 1, so minus j over there, so I have written over there. So this is the third part, second stage calculation. So 6, 1 minus j, 0, 1 plus j, whatever the points are written over there, sorry, we have calculated, we have to write down, because it is required for the third stage calculation. Third stage calculation, So the twiddle factors are like this one. Twiddle factors are W8 raised to 0, W8 raised to, because these are the half. We have to calculate it for half. So W8 raised to 0, 8 raised to 1, 8 raised to 2, 8 raised to 3. So W8 raised to 0 is how much? 1 e raised to 0 over there. So W8 raised to 1 is how much? You have written over there. E raised to minus j 2 pi 1 by 8. So this, if I am calculating, so I will get 4 over there. So e raised to minus j 5 by 4. So if I am splitting in cos and sin phi, so cos minus j 5 by 2 minus plus j sin minus 5 by 4 over there. So from this I will get the value as 1 by root 2 minus j 1 by root 2. So if you are calculating 1 by root 2, so its value is how much? 1.0.707. Its value is how much? 0.707. So you can write down like this one, 0.707 minus j 0.707. So its W8 raised to 0 is 1. So its second point, its value is how much? Minus j. And third point, its value is how much? 0.707 minus 0.707 minus j 0.707. So you have to write this. In this case, overall points are overall points are interrelated. So these are the input sequence which you have derived from the second stage. So 6, 1 minus j 0, 1 plus j 6, minus 1 plus j 0, and 1 minus 1 j. So half we have to write down, multiplier as 1, and half you have written minus 1 over there. I have written minus 1, minus 1, minus 1. And for half point, that is the odd point, we have to write down what? You have to write down its twiddle factor. So that is nothing but 1 minus 1 by root 2 minus j root 2. So j 1 minus root 2 j over there. So you have to write down like this. So just I will rub the portion first. So 6 into 1, 6 I rated, and it is coming over there. Means what we are doing, we are calculating, we are one even sequence and one even sequence and one odd sequence. One even sequence and one odd sequence. We are adding that one with twiddle factor. What we are doing in this case, when we are taking one here, this is even, okay, and here this sequence, we are adding this two in the last stage. We are in the last stage, we are adding this two. Okay, so we are doing this thing, 6 plus 6, we are getting 12. That is nothing but x of 0. Then second stage, 1 minus j, I have written over there, plus this 2, this sequence, this keep in mind what we are doing, this one. So minus 1 plus j into this twiddle factor, we have to add this 2. So resultant will be 1 plus j 0.4, not 4. Second stage, 0 as it is, and if I am pressing this thing, 0 into anything you are getting 0. So 0 into 0 anything you are getting 0 only. For fourth point, what we are doing, fourth point we are getting 1 plus j, and is it as it is, and the 4 point is like going like this one. So it is nothing but minus 1 minus j into the last total factor, that is nothing but the minus 1 by root 2 minus 1 minus j 1 by root 2. So if you are doing this thing, multiplying this thing, we are getting 1 plus j 2.1414. Okay, like this, and you have to calculate the remaining all the points, and this whatever this resultant sequence is like this one. What is this? 12, 12, then 1 plus j 404, 0, 1 plus j 2.414, 0, 1 minus j 2.1414, then again 0, 1 minus j 0.1414. Okay, so this is the output of the sequence, that is by using DIT algorithm. So if you are having any doubt, so you can mention in the comment box, and remaining portion of this odd part you have to calculate. Okay, I have given over there, you can pause the video and you can solve it for this. I have calculated for 4 points, I have calculated for 4 points, remaining 4 points you have to calculate. So now remember that the structure of the butterfly diagram is similar for every problem. This butterfly structure is same one. You have to remember this structure. Don't forget, because this, if you are drawing the structure, it is very good. So I think this is well enough for today's lecture. So thank you very much for attending this lecture. Thank you.